the question. We have a battery here, and there is a 6 microfarad capacitor and a 12 microfarad capacitor, and they both are connected in parallel connection, and you have 3 microfarad in series with this, and they've given that the energy in the 6 microfarad is E. The energy in 6 microfarad is E. The energy in 12 microfarad will be 3E because the potential is a constant. They're using the formula half C V square for the top one and half C V square for the bottom one, where the voltage is the same. So this is 6 and this is 12. So 1 is to 2 ratio. Therefore, energy is E and 2E. Energy is 2E and 2E. I'm sorry. So then the total energy becomes 3E. And what is the formula for total energy? Half into equivalent capacitance is 18 into 10 to the power minus 6 into V square. So this is 3E. And this and this get cancelled. 9 into 10 to the power minus 6 into V square is equal to 3E. The 3 and 3 get cancelled. 3 into 10 to the power minus 6 into V square is equal to E. So thus you get the E's value in terms, okay, and you know V is equal to Q by C, 3 into 10 to the power minus 6. And um, you can write as Q square by C square, where C has to be the equivalent capacitance in here, which is 18 C1 plus C2, 18 into 10 to the power minus 6, because C1 plus C2 is 18 microfarad. And C1 plus C2, the whole square, because Q square by C is 18 to the power minus 6. Q square by C square, okay, because it's V square. V is equal to Q by C is equal to E. Then this will be cancelled as 3 into 10 to the power minus 6 will get cancelled. You will have an 18 into 18 into 1 of the 10 to the power minus 6 will be there. This will become 1 by 6. And this will become 1 by 8 6 are 48. 6 ones are 6. So it's 108 into 10 to the power, it's 10 to the power 6. So it's 1 by 108. That will be my, that will be the mm, into Q square will be E. Therefore, Q square itself is 108 into E into 10 to the power minus 6. Once you get this, it's the same charge that's going to come out of this also. You can use the formula half Q square by C. So half into what is Q square is 108 E into 10 to the power 6. 108 E into 10 to the power 6 by the capacitance 3 into 10 to the power minus 6. This and this gets cancelled. This is 3 ones are 3. 3 threes are 9. 6 threes are 18. And this will become 18. And thus it becomes 18E. And that will be the energy in this. So it's 18E. That's the energy. I hope I've done it correctly. So make sure that you're not doing any calculation mistake. If I have, please point out. I'll go to the next question. So the next question is the 19th question. So you have a C4, a capacitance C3, and you have a C2 and a C1 which are in parallel. They've given this to be 3 microfarad. C1 is 3 microfarad. C2 is 6 microfarad, and 3 microfarad. And then you have a battery like this. And that voltage, I don't know what is the value given here. I can't see it properly. Is 8 volts. Huh? It's 8 volts, I think. Yes. So then, therefore, these two are in parallel. And what about the values of C3 and C4? It's 4 microfarad, and this is I think 12 microfarad. So these two are parallel, so it will become 9 microfarad, and 1 by 12 plus 1 by 4 plus 1 by 9, and the LCM for this can be um, 12 into 9 into 18, 108. Okay, so 12 nines are, and this is 9 12s are, and this is 4 2s are 7 fours are 28. So this will become 9 plus 27 plus 12. So then that becomes 21. 27 plus 21 is 48 by 108. So it's 108 by 48, which is 52 by 24, which is 2 ones are 2. 6 twos are 12 by, so it's 8 by 6. And it's been reciprocal already. So this 8 by 6 or a 4 by 3. So that is the equivalent uh, capacitance in this, and that has to be yeah, so that's the equivalent capacitance for entire circuit 4 by 3. And so charge is equal to C equivalent into voltage, which is 4 by 3 into 8. So it will be 4 by 3 into 8. Oh, so nothing is getting cancelled. It was 32 by 3 coulomb. So I'm not sure if this is microcoulomb, right? It's microcoulomb. So here also it will be micro. This is microfarad, so it says microcoulomb. So I hope my LCM is correct. So 1 by 12 plus 1 by 4 plus 1 by 9. Why can't I keep the LCM as 72? 9 eights are 72. Okay, 4 ones are 4, 8 fours are 32. And this is 12 six are 72. So it will be 6 plus 18 plus 8. In case I made any mistake, I'm just trying to see. It will be 36, 30, 26. So 32 by 72. I don't know. Okay, then just cancel it with two tables. 2 ones are 2, 6 is 12. 3 to 6, 6 to 12. So again 8, 2 ones are 2, 18. So a 4 by 9. Oh, what? I'm getting different answer. Okay, so then this calculation, some mistake is there, I think. 12 6 is 72, 8 4s are 18 4s are 72, and 9 8s are 72. So it's 6 plus 18 plus 8, 26. So 32 by 72. So 4 by 9, you have to reciprocal it. So it will be 9 by 4. So if it's 9 by 4, it makes sense because it's 9 by 4 into 8. So 9 by 4 microfarad. Okay. So it's 9 by 4 into 10 to the power minus 6 into 8 will make it 18 into 10 to the power minus 6. So 18 microcoulomb. So thus you get the total charge. What is the question? Calculate the net capacitance. Already done. I made a mistake here. I hope you are clear. And then next is if the charge on the capacitance C1, oh, they didn't ask for equivalent capacitance, okay? The charge on the capacitance C1 is 6 microcoulomb. Yeah, 6 microcoulomb. The charge on this itself, in capacitance C1, sorry, this is C2. In capacitance C1 is 6 microcoulomb. The charge on this. And you know, Q is equal to C into V. The potential again is going to be the same. And here also it's Q is equal to C into V. The potential is the same. So the only thing which is a variant is here it's 6, here it is 3. And so then it will be in the ratio 2 is to 1. So if you're going to have the charge here is 6 microfarad coulomb, obviously the charge in this will be 12 microcoulomb. So thus you get the charge in the top one to be 12 microcoulomb. The question is calculate the charge on the capacitance. C2 you got 12 microcoulomb, but they're asking for uh, the charge on this and this, okay? So you know that you can add both the charges, which is 12 microcoulomb plus 6 microcoulomb, which will be 18 microcoulomb, and this whole thing will be 18 microcoulomb. Once you get the charge that is flowing through this here, which is 18 microcoulomb, you know the respective capacitance, you can find the potential you want, but the question is only about finding the charges. It's the same charge in C3 and C4. It's the same. The net energy stored in the capacitance C3 and C4. So the net energy is half Q square by C. And the charge is going to remain the same, 18 into 10 to the power minus 6 the whole square. And the net capacitance between these two, they're not individually asking. Energy stored in the capacitors C3, net energy stored means you have to find the total energy. So can we do the equivalent capacitance here? It's 12 into 4 by 12 plus 4. So it's 12 fours are 48 by 16, which is 3. Can we substitute 3 into 10 to the power minus 6 here? So that I get the net energy, because I've calculated the net capacitance and I know the total charge. So you get the answer. So that will be the answer for that. And I'm not doing it. You can do your own calculations. So let's go to 20th question. 20th question is the tabular column, which I've already taught you. So I'm not going to deal with that now. So let's go to 21st question. There's n droplets, which is going to coalesce to form a bigger droplet. So you write n into 4 by 3 pi small r cube is equal to 4 by 3 pi capital R cube. 4 by 3, 4 by 3 pi get cancel. N to the power 1 by 3 into r is equal to capital R, and this is the relation. They're asking for the potential on the bigger droplet. Charge on the bigger droplet. If the charge of one droplet here is q, the n such droplets, so nq is the total charge. And they are going to ask you for the potential of the bigger droplet. It's 1 by 4 pi epsilon naught into charge is nq by capital R, which will be n to the power 1 by 3 into r, small r. So you can take it up. This can be written k n to the power 1 minus 1 by 3 is n to the power 2 by 3 into q by r. It is in terms of smaller. I what have they given? Have they given smaller? How will the following vary with respect to smaller droplet? The total charge on the bigger droplet is n times the original smaller droplet. The potential on the bigger droplet and a smaller droplet is kq by r. So it is n to the power 23 times the older potential of one droplet. The bigger droplet will be n to the power 23 times. Okay, n to the power, sorry, 2 by 3 times. Okay, I'm too tired, guys. Okay, anyway, let me continue because PSCNA has got exams. So let's go to sum number 22. They've given this to be a positive plate and this to be a negative plate, and you have a dielectric slab of thickness D, and you have a metal conductor, metal plate, and this is dielectric. Okay, this is also of distance D, and this separation is also D, this is also D, this is also D. Can you see that totally there's a gap of phi D? And there will be an electric field E, and there will be reduced E naught, and there will be reduced electric field here. And the E naught will exist for a gap of phi D minus 2D, because here there's dielectric, we have to ignore. Here there's a metal plate, I have to ignore. So then therefore that exists, and there is for this dielectric, here there's reduced value of electric field will exist. And so that will be the reduced value of electric field for a thickness D. In the metal plate, there will be nothing. Okay, so this is, and you can write this as E naught by K. So E naught can be taken out common. This will be 3D plus D by K. So E naught into D can be taken out common, 3 plus 1 by K. What is the question? Sorry. Um, Find the potential difference between the ends of the plate. Oh, that's what it is. V is equal to, we found the potential difference between the ends of the plate. And plot a graph between E versus X, where X is equal to 0. Starting from this plate, you write X is equal to 0, then D, and then up to 5D. So you have to plot a graph taking from the positive plate to negative plate between E versus R. And electric field E versus X graph. So now plotting E versus R, this will be D, this will be 2D, there will be 3D, there will be 4D, and there will be a 5D, and so on. And electric field, they're asking you to plot a graph in E. And E is equal to, is the negative of potential gradient V by D. So the potential, you have to divide it by D, and so D alone cancels off, correct? So you got the potential, okay. But at every position you have to check. At this position, what will be the electric field? Electric field, there's no dielectric or anything, so we can call it as some E naught, which is the applied existing electric field E naught. The initial electric field is E naught. So next between this, there's a dielectric. So when the dielectric is inserted, you know that it will become E naught by K, because it's not V. Okay, it is between electric field. So then therefore it becomes E naught by K. And then between so the graph will be like this, and then like this, Between 2D and 3D, there's again another gap only, so applied electric field, and that is existing electric field, initial electric field. And 3D and 4D, 3D and 4D, there is no electric field at all because it's metal plate, so draw it here. And 4D and 5D is vacuum, so you have E naught. So whenever there's vacuum, it's E naught. Whenever there is a dielectric, it gets reduced by, because E is equal to V by D, and V itself has got, uh, what to say, um, for the first one, when there is gap, the electric field is E naught and the distance is D, and V is equal to E naught into D, so E naught is equal to V by D. So that's it. For the second gap, there is a dielectric, and when the dielectric is inserted, um, you know that the potential is going to be different, and it's going to get, the potential is going to be, V is equal to E naught into dielectric. So it's, that's reduced value of electric field. That is what is called reduced value of electric field. No. So how does it get reduced? It get reduced by K. Just remember that. So this is the graph. This is the graph. So you understand, this the way you have to draw the graph. It's graph between electric field and position vector, not. So then it has to be the E naught by K. Okay, so because the electric field is going to get reduced because of the dielectric, because of the reduced value of electric field, right? So I hope you're clear. Remember the derivation, and that's very, very important. So let's go to next question. The next question is, again, I can't see the question properly. Mm, mm. So I don't know what is the next question. Something is wrong with, some question which has got two parallel conducting plates of area and surface charge density plus sigma and minus sigma. Okay, so two parallel plates, one with the surface charge density plus sigma, another with the surface charge density minus sigma. Okay, and a dielectric slab of constant K, and a conducting slab of thickness T. So there is a dielectric slab. Isn't this the same sum? Yeah, so that sum is over. Okay, so that sum is over. So the next question is, you have a 3 microfarad here and a 3 microfarad here, and you have a 2 microfarad here, and you have 1 microfarad here, and you have a 2 microfarad here. Sorry guys, it's again hanging. It's again hanging. So redraw the circuit. So you have a 3 microfarad, a 3 microfarad, a 2 microfarad, a 1 microfarad, and a 2 microfarad here. This is 2 microfarad. This is 1 microfarad, 2 microfarad, a 3 microfarad. Please forward the video and listen. And a 3 microfarad. You have some circuit like this. This has been connected to a 100-volt supply, and you know that, you're going to solve this. Mm, we can keep, this and this, 3 and 3 is in parallel, and this and this is in parallel. So it's parallel 6 microfarad. This is parallel, it will be 1 and 3 microfarad, and they both will be in series. So 6 into 3 by 6 plus 3, which is 18 by 9. So it's 2 microfarad altogether on the top. That 2 with this 2 will be in parallel. So 2 plus 2, 4 microfarad. We already given the voltage, so you can find the charge, whatever they ask you to find. Total energy, equivalent capacitance itself is 4 microfarad, half CV square, half into 4 into 10 to the power minus 6 into 100 the whole square will give you the total energy. Calculate the total energy of the network. That's all. But there's something else given. The ratio, find the ratio of the potential differences that must be applied across the parallel and the series combination of two capacitors C1 and C2. with the capacitances in the ratio 1 is to 2. So the energy stored in the two cases becomes the same. Oh, that's a different question. Oh, there is another question here. Sorry, find the ratio of the potential differences that must be applied across the parallel and series combination of two capacitors C1 and C2. The capacitances in the ratio 1 is to 2. So C1 by C2 is in the ratio 1 is to 2. The energy stored in the two cases becomes the same. I left this sum completely. So I've done the sum. I don't know if I'm making any calculation mistake. The given C1 by C2's ratio is 1 is to 2. So I'm writing therefore C2 as 2 times C1. We're going to connect these two capacitors in parallel and connect these two in series and find out what the ratio of the potentials has to be. The energies are the same in both. This is equivalent capacitance 3C1. In this, the equivalent capacitance 1 by C1 plus 1 by 2C1. 2C1 is the LCM. So 2 plus 1 is 3 by 2C1. So then therefore it's 2C1 by 3 is the energy, is the equivalent capacitance. So then the energy in this is so much, the energy in this is so much. So if ratios of their, they have to have the same potential, they have to have the same energy, is it? Do they have to have the same energy? Show that the energy stored in the two cases becomes the same, which means I can just equate it. Just equate it, and 1 by 2, 1 by 2 get cancelled, C1, C1 get cancelled. So I get, therefore, V1 square by V2 square will be 2 by 9. And V1 by V2 will be root 2 is to 3. Is to 3. If I made any mistake, please correct it. The calculation only could be wrong, otherwise everything is correct. Calculation also could be correct only. Just make sure you're getting the right answer. If not, you let me know. So let's go to next question. Is about this question where I was drawing this capacitance. And in this, what were they asking? The five capacitors connected to 100 volts supply. Calculate the total energy, which we already just do the calculation of this. You get the answer. That is done. So that completes the 22nd question. Let's go to 24th question. The 24th question is the 3 points A, B, and C lie on a uniform electric field. Electric field's value is 5 into 10 to the power 5 Newton per coulomb. Find the potential energy difference between A and C. Look at this. There's an uniform electric field like this. Okay, there's an A, there's a B, and there is a point C. And this distance is 5 centimeter. This distance is 1 centimeter. And so we can find what is AB's distance. Therefore, it's root of 25 minus 1, which is root of 24. 6 4 so 24. So 2 root 6, whatever it's worth, I'm writing that. But what is the question? Find the potential difference between A and C. The potential difference between A and C is just this potential here. At this point, what is the potential? This point, what is the potential? It just you have to find. That's all. So you find the potential here. So you know that find you do you know the potential at A 3 points AB is say lie in the uniform electric field. Find the potential difference between A and C. So between A and C, there will be. Do you think there will be any potential difference? You know, E is equal to V by D. V is equal to E into D. Correct? Oh, guys, I've copied this wrongly. I can't see it properly. It's 3 centimeter. I'm sorry. If it's 3 centimeter, it's 25 minus 9 will be 16. So this will be 4. And you know, E is equal to V by D. V is equal to E into D. The potential at A and potential at B is the C is nothing but potential at B. And it's lying on the same point, vertical, you know. So then potential at A, you can do a potential between A and B, which is E into D, which is E into, what is the E value? 5 into 10 to the power 5 into distance itself is 4. So that will give me my V. V is equal to E into D. So it's 5 into 10 to the power. Again, it is not 10 to the power 5. This is 10 to the power 3. Okay, and 4 is a centimeter, so 4 into 10 to the power minus 2. Just use the Veda mantra and find what is the potential, thus you get 200 volts. The thing that you should know is potential at C, the same as potential at B. And potential is based on electric field, and electric field is based on electric force, which is a conservative force, does not depend on the path taken, so it justly depends on the so then even otherwise it's difference between A and B, because C is nothing but the potential at B and C are same. So that completes this question. So next question is the 25th question. 25th question. uh, Two capacitors of unknown capacitance C1 and C2 are connected first in series and then in parallel. So first in series and then in parallel. Okay, across a battery of 100 volts. Across a battery of 100 volts. If the energy stored in the two combination, in this combination 0.45 joules, in this combination 0.25 joules, determine the value of C1 and C2. Also calculate the charge on each capacitor in the parallel combination. So the charge on each capacitor, and then calculate the determine C1 and C2. So this is C1, this is C2, this is C1, this is C2. Here the equivalent capacitance is C1 plus C2. And the energy is half into C1 plus C2 into 100, the whole square itself is 0.25. So C1 plus C2, 0.25 into 2 is 0.50 into 10 to the power 4 is equal to 0.50. The C1 plus C2 itself is 0.50 into 10 to the power minus 4. Or you can say it's 50 into 10 to the power minus 6. So C1 plus C2 itself is 50 microfarad. Okay, so next is look go for this where it's C1 C2 by C1 plus C2. So half of C1 C2 by C1 plus C2 into V square, which is 100 the whole square, is equal to 0.045 or 0.45 or 0.045 or 0.045 only. So then therefore this goes that side, will become C1 C2 by a C1 plus C2 itself, it's 50 into 10 to the power minus 6, which will be equal to 0.090. This is 10 to the power 4, when goes this will become 10 to the power minus 4. So C1 C2 is equal to, multiply these two. So you have linear equation C1 plus C2 and you have C1 C2. Write one in terms of the other and solve it like linear equation. Hence you get C1 and C2 individually. Also calculate the charge on each capacitor. Once you know the C1 and C2, the potential is V. So the charge is Q is equal to C1 into V, and Q2 is equal to the charge on this will be C2 into V. So once you get C1 and C2, plug it in there, you get the answer. So let's go to next question, which is a 12 picofarad capacitor. 12 into 10 to the power minus 12 farad capacitor is connected to a 50 volt battery. How much electrostatic energy is stored in the capacitor if another capacitor of 6 picofarad is connected in series with it, with with the same battery? It's connected in series across the combination. You're connecting, okay, so it's only series. Okay, this is 12 into 10 to the power minus 2. Another is 6 picofarad, 6 into 10 to the power minus 2 farad is connected in series with the same uh, battery of 50 volts. Find the charge stored and the potential difference across each capacitor. 12 picofarad is connected to 50 volt battery. How much electrostatic energy is stored in that capacitor in this case? It's just half CV square, that's all. So it's half into 12 into 10 to the power minus 2 into V square is 50 the whole square. So calculate that, you get this, and then so just do the calculation. This will become 6. This is 6 into 10 to the power minus 2 into 2500. 6 5s are 30, 6 2s are 12 into 10 to the power 2. So 150 is my energy. Is it correct? 12 into 10 to the power minus 12. Minus 12. 10 to the power 2 will become 10 to the power minus 10. So it's 15 nanojoules, 10 to the power minus 9. So 15 nanojoules is the energy in the initial one. So now, in another, if another capacitor 6 micro picofarad is connected in series with the same battery, find the charge stored and potential. Okay, this is series, so 12 into 6 by 12 plus 6. I'm sure you can do this by yourself, guys. 18 4s are, is it? So it's 4. Is it picofarad? If it's picofarad, you have to write it as picofarad. Yeah, minus 12. Okay, everywhere it's minus 12. So 4 picofarad is the equivalent capacitance. So then calculate you the C equivalent into voltage. Voltage is still 50. So 4 into 10 to the power minus 12 into 50 is again it's hanging. I'm sorry. I'm done with this. Okay, I'm not doing anything more, guys. I'm done with the recording.